All right, good morning and welcome to Master Talker online class. Today's video we're talking about heat energy, right? Okay, so right for me, heat is a form of energy, full stop. It is therefore measured in joule. Since it's a form of energy, it is measured in joule as heat SI unit, right? So the quantity of heat gain or loss by a substance is measured using an instrument called calorimeter. So the instrument used in measuring heat is called what? Calorimeter. It's an exam question. Very, very important. So the next thing you need to know is the difference between temperature and heat. Okay, write that for me. Difference between temperature and heat. Number one, heat is a form of energy, but temperature is not a form of energy. Number two, heat is measured in joules, okay, while temperature is measured in Kelvin or degrees Celsius. Okay, quantity of heat is measured by calorimeter, while temperature is measured by thermometer. All right, heat is a measure of the total inner energy of a substance, while temperature is the degree of the is a physical quantity, right? And it is a degree of the measure of the coldness or the hotness of a body, right? The measure of the degree of the coldness or hotness of a body. Now note, temperature determines the direction of heat flow when two bodies are in thermal contact. That is when both of them have different temperature. Another thing you need to know is that what? Heat is equal to what? MC change in temperature. Very important. Where my H is equal to what? Heat energy measured in joules. Okay, then my M is what? The mass of that body, the mass measured in kg. Okay, my C is what? My specific heat capacity measured in joule per kg per Kelvin. Okay, joule per kg per Kelvin. So the next one is what? My theta 2. This thing is same as saying MC. This change in temperature can be written as theta 2 minus theta 1. Okay, very important. So we'll write it as my M2 is what? The final temperature. While my theta 1 is equal to what? My initial temperature. Okay, so they are both measured in Kelvin, or degrees Celsius, anyone you like, or you say degrees Celsius or degrees Celsius. Okay, so that is that. So write a subheading for me: specific heat capacity. Okay, we write them as, we represent it with C. Right, the specific heat capacity of a body is defined as the quantity of heat needed to raise the temperature of a unit mass, that is of 1 unit mass of a body to 1 Kelvin. Okay, the energy needed, okay, the quantity of heat energy needed to raise the temperature of a unit, just 1 unit mass of a body to 1 Kelvin. All right, from this our formula that we say that heat is equal to what? MC change in temperature. We will now make our C subject to have what? H all over what? M change in temperature. M change in temperature. You will know that what? Heat is measured in joules per is because of this divide. M is measured in kg, while temperature is measured in what? Kelvin. That is why the SI unit is what? Joule per kilogram per Kelvin. All right, so that is that. So the next thing you write for me is that, now if you look at this, you will see that what? That the heat supplied to a body depends on the mass of that body. Okay, number two, the nature of the body. Then the nature of the body is called the specific heat capacity. That is the nature of the body. Then finally the temperature. So they can ask you that the heat energy depends on what? First, it depends on the mass. Second, the specific heat capacity, which is the nature of the body. Then finally it is dependent on temperature. All right, so the next thing you write for me is thermal or heat capacity. Know that there is a difference between specific heat capacity and heat capacity. Okay, heat capacity heat capacity is simply the product of, we'll call it MC, the product of mass and the specific heat capacity. It is the product of mass and the specific heat capacity. They say that heat capacity of a substance is defined as the amount or the quantity of heat required to raise the temperature of a whole body of the substance through 1 kg, and it is denoted by MC measured in joule per Kelvin. All right. So if you, from this same formula, we have that H is equal to MC change in temperature. If we make our MC subject of formula, we have that H is equal over what? Change in temperature. So that's why it's measured in what? It's measured in joule per what? Per Kelvin. Okay. So know the difference between specific heat capacity and heat capacity. If you are talking about the specific, then it is just C. But if you just heat capacity, is MC. All right. So the next thing I need you to know is what? The method, different method of calculating the specific heat capacity of a body. Okay. Different methods of calculating methods used in finding the specific heat capacity of a body or a substance. The first method is called the mixture method. The mixture method. Mixture. Okay. Now, in the mixture method, we know a simple formula that said that what? H is equal to what? MC change in temperature. Okay. Then another thing you need to know is that what? Heat gained is equal to heat loss. Heat gained is equal to heat loss. All right. That's for that. Okay. Now, number two you need to know is by electric method. Electrical method. Now, the electrical method shows that what? That electric energy, I will show you what I mean by this particular one. Okay. Okay, you should know that what? That M1 C1 theta 2 minus theta 1, okay, because it is gained, okay, is equal to, let me say, M2 C2. Then we can have theta 1 minus maybe theta 3 because it is lost. I will show you that. We'll solve some questions to illustrate that. All right, don't bother. Okay, let's come to this. Electrical energy is equal to heat energy because energy is equal to energy. Now, if you remember in electricity, or if you have not watched our video on electricity, please do that so you can remember electricity. That said that energy is equal to IVT. IVT is energy, okay, which is equal to my heat energy is MC change in temperature. All right. Now, don't forget that what? That power is equal to 4, which is IV. Power is 4. Okay. So if I replace this 4 with power, I will have that what? PT. PT is now what? MC change in temperature. Okay. And don't forget that I is equal to what? V is equal to IR. Let's start from that. V is equal to IR. So if I represent V with IR, I'll have I times I squared. Then I have what? R. Then my T. Then is equal to MC change in temperature. So don't forget again that my I is equal to V over R. If I replace I here, the same formula is what I'm using. This is the main formula. This is the main formula. From here, you can derive anything you want. But the one I want you to know is only this one. Okay? Then you now know. So if you now put that our I is equal to V over R, I will now have that what? V squared over R. Then I put my T is equal to MC change in temperature. Okay? And so on and so forth. That is for my electrical method. Then the final method, which is the third one, is what? The mechanical method. The mechanical method. Now, the mechanical method said that what? That potential energy is equal to heat energy. And what is potential energy? The formula is what? mgh is equal to what? MC change in temperature. Don't forget. Or you said that what? Kinetic energy is equal to what? Heat energy. Okay? So what is formula for kinetic energy? Half mv squared is equal to what? My heat energy is still my MC change in temperature. Okay? You say that work done is something as what? Heat energy again. And what is work done? Force times distance is equal to what? My MC change in temperature. So that is all you need. So let us now solve calculation to illustrate what we have written so far. Okay? The first question said, question number 1 said calculate the quantity quantity of heat energy. Calculate the quantity of heat energy needed to raise the temperature of 450 gram of copper from 30 degrees Celsius to 80 degrees Celsius. All right. Then the next say you should take the specific heat capacity of copper to be 400 joule per kg per Kelvin. Solution. Okay. Let's take out our parameters. The first thing they gave me is the mass. My mass is 450 gram, which is what? 450 divided by 1000, which is 0.45 kg. Okay. The next thing they gave me is the temperature. My theta 1, the initial temperature 30 degrees, and my theta 2, 80 degrees Celsius, and my specific heat capacity 400 joule per kg per Kelvin. All right. And I know that my heat is equal to what? MC change in temperature. So my change in temperature, let me get my change in temperature, which is what? Theta 2 minus theta 1, which is 80 minus 30, which is what? 50. So you now have my M is 0.45 times my C is 400 times my change in temperature is 50. So if you multiply everything, you'll be having 9,000 joule, which is what? 9 kilojoule. Okay? Very, very simple question to calculate. The second question, we have number 2. Number 2 said the temperature of a piece of metal of mass 9 gram is raised from 10 degrees Celsius to 110 degrees Celsius when it absorbs 108 joule of heat energy. Then I say find the specific heat capacity of the metal. Solution. Okay? Very simple. What did they give us? Let's start from what they gave us. They gave us mass, and the mass is 9 gram. And 9 gram is something as what? 9 divided by 1000, which is what? 0.009 kg. Okay? The next thing they gave me is theta 1. My theta 1 is what? 10 degrees Celsius. And they gave me my theta 2. My theta 2 is what? 110 degrees Celsius, which will help me to get my change in theta. My change in theta will now be what? Theta 2 minus theta 1, which is 110 minus 1 minus 10, which is 100 degrees Celsius. Okay? That is my change in temperature. So what else they give me? They gave me my heat. My heat is equal to 108 joules. But I know that they now say I should calculate my C. Okay? I know that my H is equal to what? MC change in temperature. Very simple formula. MC change in temperature. So my C will now be what? H divided by my M change in temperature, which is what? My H is 108 divided by my M is 0.009 times my change in temperature is 100. So if you do that, you'll be getting 120 joule per kg per Kelvin. Okay? You see? Very, very simple question. Question number 3. Question number 3 said that water of mass, 5 kg at 30 degrees Celsius absorbs 8.4 times 10 raised to the power 5 joule of heat. Then I say neglecting heat losses to the surroundings, calculate the final temperature of water. Calculate the final temperature of the water. Okay? Solution. Now, what did they give me? They gave me the mass of water, which is what? 5 kg. They gave me theta 1, which is 30 degrees Celsius. they say I should find theta 2. Okay, my C, whether you are given or not, you should know that the specific heat capacity of water is 4,200 joule per kg per Kelvin. Please note this. The specific heat capacity of water is 4,200. Then they now give me the heat absorbed, 8.4 times 10 raised to power what? 5 joules. I know that my H is equal to MC change in temperature. First of all, let me get my change in temperature. My change in temperature will now be H divided by my MC, which is what? 8.4 times 10 raised to power 5 divided by 5 times divided by 4,200. So if you do everything there, you'll be having 8.5 times 10 raised to power 5 divided by 4,200 divided by 5. And I have 40.47 or 40.48 degrees Celsius. But I know that my change in temperature simply means theta 2 minus theta 1. Okay, theta 2 is my final, so this one will move here. So I now have that theta 2 is equal to change in temperature plus theta 1, okay, which is 40.48 plus my theta 1 is 30, so which will give you 70.48 degrees Celsius. Very, very simple question. Okay, question number 4. Question number 4. Let me clean here. Right? Question number 4 said a piece of copper, Cu, a copper ball, okay, spell your own, a copper ball at 80 degrees Celsius is quickly transferred into a copper calorimeter of mass 60 gram containing 200 gram of water, okay, at 25 degrees Celsius, full stop. Then I said if the final temperature of the mixture is 55 degrees Celsius, okay, comma, then I say calculate the mass of the copper ball. Then I say ignore heat loss and take the specific heat capacity of copper to be 400 joule per kg per Kelvin. Okay, so that is all they gave us. Solution. Now, then I said what? A piece of copper of okay, let's say that this copper is the first thing they mention, copper ball. So let's say the mass of the copper ball should be M1. Let everything about the copper be M1, be 1. So M1 is the mass of the copper ball, which we are asked to find. Calculate the mass of the copper ball, unknown. So now they gave us the temperature of this copper ball. So my theta 1 is equal to what? 80 degrees Celsius. Okay, is quickly transferred into a copper calorimeter. Calorimeter is the next thing mentioned. So let everything about calorimeter be 2. So the mass of the calorimeter, M2, is equal to what? Then C1 is going to be the mass of the specific heat capacity of the copper, which they gave me as what? 400. Okay, we are going. So the next thing we are asked to do is what? What else? Okay, they say that the mass, what am I saying? Now M2 is now the mass of what? We're not talking about calorie. Everything about calorimeter should be 2. So the mass of the calorimeter is what? 60 gram, which is what? 60 divided by 1000, which is 0.06 kg. Okay, now we need theta 2. Theta 2 is the temperature of that calorimeter. Okay, they say containing 200 grams of water at this temperature. Then I said if the final temperature is this. Okay. Do we have the temperature of the calorimeter? Okay. Now, okay, the temperature of the calorimeter is the temperature of that water, because once you put the calorimeter inside that water, it will now be showing the temperature of that calorimeter. So the temperature of calorimeter is still the temperature of the water, which is 25 degrees Celsius. Okay. So then the next thing is our C2. Our C2 is what? The specific heat capacity of the calorimeter. The specific heat capacity of the calorimeter. Well, are we given that? Our C2, okay, is the specific heat capacity of the calorimeter. But we cannot get the specific heat capacity of the calorimeter. Rather, we can get, we will take it as the specific heat capacity of the, in fact, okay, thank you. If you look at this now, you see that what? This calorimeter is made with copper. This calorimeter is made with copper. So since the calorimeter is made with copper, the specific heat capacity of this calorimeter is still the specific heat capacity of copper. You see what is happening here? So since it is made with copper, so the specific heat capacity here will be 400 joule per kg per Kelvin. So the last thing, is there another thing about 2? There are 3. 1, 2, 3. 1, 2, 3. Let's go to the third one. Now, they say containing 200 grams of water. Now, let's use 3 for water. Okay, so therefore, my MO3 is mass of the water. And what is mass of the water? 200 gram, which is what? 0.2 kg. That's divided by 1000. So our theta 3 should be the temperature of the water. And what's the temperature of the water? 25 degrees Celsius. Okay, so what else? So then our C3 is what? The specific heat capacity of water. Even if you are given or not, we know it as what? 4200 joule per kg per Kelvin. Don't forget. And then we are done. You should know that what? Heat loss is equal to what? Heat gained. Okay. Now, but if you look at this, what? The only thing that lost water, the only thing that lost heat was the copper, because the copper was heated. That is why it was quickly put inside that water. So the only thing that loses heat was only the calorimeter. So I'm going to have for this side as what? M1C1 change in temperature, and the change in temperature should be the final temperature minus the temperature of that 111. I'm using 111, but since it is loss, if it is loss, I'm going to say the initial minus final because it is loss. So I'm supposed to say theta 1 minus theta 3. Okay, theta 1 minus theta 3, because I'm talking about loss. But for gain, should be normal. Okay, now for gain, the thing that gained energy, the calorimeter gained energy. The water itself, gained energy as well. What type of energy? Heat energy. Okay, so because when the other one was hot, it was put inside them, then they now gain energy. So for the calorimeter, which is 222, we have what? M2C2 change in temperature, and my change in temperature should be what? Theta 2. The final temperature. What is the final temperature there? We say that the final temperature. What's the final temperature? Theta what? Did we get theta 3? Sorry. Our theta 3 should be the final temperature. So our theta 1, 80 degrees Celsius. Our theta 2, in fact, the temperature of the water. This is the temperature of the water. Let me call it the final temperature there should be theta 3. How do I explain this thing for you? Okay. Well, let me call it that the final temperature is what? Let me call it theta 4. Theta 4 is the final temperature. Let me use theta 4 as the final temperature. Okay. This is the final temperature. Theta 4 as the final temperature. And the final temperature is what? 55 degrees Celsius. Okay, so let me now use my formula. So the formula is what? Anything change in temperature is what? This final minus anyone you want to use. So for this side should be what? M1C1 into, it should be the final theta 4 minus itself theta 1. Okay, but since it is loss, I told you that this side is for loss, and the only thing that lost was the copper itself. So it will now change to the initial minus the final. So the 1 here minus the 4. You get why I did this? So the other one should be what? M2C2 into, it should be what? That final theta 4 minus that of that calorimeter, which is 25. That is theta what? 2. Okay? Plus, because two people gained energy there. So I have M3C3 into what? Theta 4 minus theta 3. Because they are all gain. Okay? So now, applying them, my M1 is unknown. I'm looking for my M1, but my C1 is 400 times 400 in bracket of my theta 1. My theta 1 is 80 minus my final 55 is equal to my M2. My M2 is 0.06 times my C2 is 400 into my, this thing is what? 55 minus what? 25 plus my M3 is 0.2 times my C3. My C3 is 4,200 into my theta 4, 55 minus 25. Okay? So let us now do that. If you subtract this, you are going to be having, let me still check if you still reading. Okay. So if you subtract that, you are going to be having 80 minus 55. You now have 25. 25 times 400 times 400. You now have 10,000 M1. 10,000 M1 is equal to, multiply this. First of all, 55 minus 25. 55 minus 25, you have 30. 30 times 400 times 0.06. So I have 720. 720 plus, let's do here, 55 minus 25. 55 minus 25, 30 times 4,200 times 0.2. I have 525200. So I have 10,000 M1 is equal to, add this, plus 720. I now have 25920. So my M2 will now be 25920 divided by 10,000. Okay? So what do I have? Divided by 10. 1, 2, 3. I now have 2.592 in kg. So that is the mass of the copper. Okay, you see, it's very, very simple. Just know that heat gained is equal to heat loss. All right. Okay, the next question, question number 5. Question number 5 said 400 gram of cold water. 400 gram of cold water is added to 200 gram of a 70 degrees Celsius, of water at 70 degrees Celsius. Then if they are properly mixed, and the temperature of the mixture, don't forget that the temperature of the mixture is the final temperature. The temperature of the mixture is 30 degrees Celsius. Calculate the initial temperature of the cold water. This is a very simple question. Okay, just know, what are you knowing? Okay, let me bring out my parameter. M1 is the mass of the cold water, which is what? 400 gram, which is what? 0.4 kg. Okay, is added to, we don't know the temperature, so let's call it theta 1 is the temperature of the cold water, which is unknown. Okay, is added to, then C1 is the temperature of what, the specific heat capacity of water, and which is 4,200, whether you are giving it to or not, joule per kg per Kelvin. Okay, so let's go to M2. My M2 is the temperature, is the mass of the second water, which is 200 gram, which is 0.2 kg. Okay, so now when I have that theta 2 is now the temperature of that second water, which is 70 degrees Celsius. Then my C2 is simply the same specific heat capacity of the second water, and it's the same thing, 4,200 joule per watt kg per Kelvin. So sorry, they say we should neglect the what? They said something here. Neglect the heat absorbed by the calorimeter. Neglect heat absorbed by the calorimeter. So just tell them that what? Heat gained, heat loss is equal to what? Heat gained. Okay, now for the heat loss should be what? M1C1 change in temperature. The change in temperature is supposed to be the final temperature theta 3. So let's say that theta 3 will now be the final temperature there. That is the temperature of the mixture, which is 30 degrees. Okay, it's supposed to be theta 3 minus this theta 1, but because it is lost, the cold one is the one gaining. Sorry, the cold one is the one gaining. So the one losing is the hot one. So the one losing is this one. Please, you should be very, very careful about the one losing and the one gaining. Cold water will gain heat. You understand? Why the hot one, the one that is at 70 is already hot, he will lose energy. So for heat loss is for this man, which is what? My M2C2. The change in temperature should be what? It's supposed to be theta 3, the final temperature, minus that theta 2. But since it is a loss, it is not a gain. So you will now change it to what? 2. And then here is 3. Very simple to understand. Is equal to, then for the gain should be what? My M1C1. Then in bracket of what? Theta 3, the final, minus that theta 1. Very simple. But C will cancel C. Why? Because they are the same thing. They are the same thing because it's specific heat capacity of water. So it's the same. So let me now put the rest. Even if you put it, you get the same answer. But to make your work simple, just cancel it out because they are the same. We know I did not put, I'm supposed to put that calorimeter gained energy, but they say we should neglect it. That's why I'm not interested in that. So my M2 is what? 0.2 in bracket of my theta 2 is 70 minus my theta 3, 30. You close, is equal to my M1, 0.4 in bracket of theta 3, which is what? 30 minus my theta 1 I'm looking for. Okay, so this and this will give you 70, 40 times this. 70 minus 30. It will give you 8. 70 minus 30. You have 40 times 0.2. You have 8. I have 8 here is equal to 0.4 in bracket of 30 minus theta 1. Okay, so divide everybody by 0.4. So 30. So you now have 8 divided by 0.4 is equal to 30 minus theta 1. So if you divide this, divided by 0.4 to have 20. So I have 20 is equal to what? 30 minus theta 1. So this one is minus coming here. This one go here. So my theta 1 will now be 30 minus 20, which is what? 10 degrees Celsius. See, this is a very simple question. A very simple question. So let us solve the next one. Heat loss is equal to heat gain. And then you are good to go. So the next question said, the next question, question number 5. Okay, this is question number 5. Question number 6. Question number 6 said, how long will it take to heat 3 kg of water 3 kg of water from 28 degrees Celsius to 88 degrees Celsius in an electric kettle taking a current a current of 6 ampere from an EMF source of 220 volts. Very simple question. Okay, now they are not talking about electricity, so let me bring out my parameters. What they gave me, they say how long will it take, so they are asking me the time. How long? The time is unknown, but they gave me that the mass here is 3 kg. Okay, and then they now say the mass of water is 3 kg. So boy, the first temperature they gave me is 28 degrees Celsius, while the second temperature they gave me is 88 degrees Celsius. So my change in temperature should be what? 88 minus 28, which is what? 60 degrees Celsius. Okay, what else did they give me? They gave me my V, EMF is what? 220 volts. And then they gave me my I, my current they gave me is what? 6 ampere. Okay, so don't forget that what? Electric energy, like I told you, electric energy is equal to what? Heat energy. And the electric energy is what? IVT. Don't forget, IVT is equal to what? MC change in temperature. So what are they asking me? My time. So my time will now be what? MC change in temperature divided by IV. So let me put it. My M is what? 3 times the specific heat capacity of water. They will not give it to you. You should know that it's 4,200. Okay? Times my change in temperature, I've gotten it as 60 divided by my I is 6 ampere times my V is what? 220. So if you do everything here, you'll be getting 572.7 seconds. As simple as that. Okay? So the next question. Question number 7. Let me check my time. Okay? Question number 7. Question number 7 said a waterfall 720-meter high. Then I say calculate the difference in temperature of the water between the top and bottom of a waterfall. Then I say neglect heat loss. Okay? Neglect heat loss. Okay? Solution. Now, this one is talking about motion. So you should tell them that what? Potential energy is equal to what? Heat energy. And potential energy is what? mgh is equal, because I have my height, mgh is equal to what? MC change in temperature. So we are talking about the same water. The water will have the same mass, so M can take care of M. So they're asking me my change in time. In fact, my G is acceleration due to gravity because it is falling. That is 10 meters per second square. Okay. My height they gave me is what? 420 meters. Okay. My specific heat capacity of water doesn't change. 4,200 joule per kg per Kelvin. Okay. Then they're asking me my change in temperature. So change in temperature will now be, that is the difference in temperature is called change in temperature. If you make this subject, you have GH over C, which is what? 10 times 420 divided by 4200, which is what? 1 degree Celsius. So the change in temperature is what? 1 degree Celsius. Okay, I can clean here. Yes. Or sometimes you say it's 1 Kelvin, anyone you like, depending on what you see in the option. Number 8 said a piece of copper of mass 24 gram, at 230 degrees Celsius is placed in a copper calorimeter meter of mass 60 gram, okay, containing 54 gram of water at 31 degrees Celsius. Then I say assuming heat losses are neglected. Okay, are negligible. Are negligible. Okay, comma. Then I say calculate the final temperature of the mixture. Okay, the final temperature of the mixture. That's all. Solution. Now let us start again. Now the first they say a piece of copper. Copper is the first thing that they told us about. So let it be 111. So the mass of the copper M1 is what? 24 gram, which is what? 24 divided by 1000, which is 0.024 kg. Okay. Now the next thing they gave us, the temperature theta 1. The temperature there is what? 230 degrees Celsius. So then the next thing is C1. C1 is what? The specific heat capacity of copper is always 400 joule per kg per Kelvin. All right. So we are done with 111. Let's go to 222. It's given with what? Is placed in a copper calorimeter. Copper calorimeter. So calorimeter is what they're telling us about. So let's take that one as 222. So M2, the mass of the calorimeter is 60 gram, which is what? 0.06 kg. Okay, 0.06 kg. So the next thing is what? Theta 2. The temperature of that calorimeter is the temperature of water. Because once you put the calorimeter inside the water, it will be showing the temperature of that water, which is what? 31 degrees Celsius. Okay, and then C1. C1 is what? The specific heat capacity of the calorimeter. But that calorimeter is a copper. So the specific heat capacity will now be 400 joule per kg per Kelvin. Okay, we are done with 222. Let's go to 333. MO3 is the mass of the water, and the mass of the water is what? 54 gram, which is what? 0.054 kilogram. Okay, then the next one is what? The temperature of that water. The temperature of that water, theta 3, is equal to what? 31 degrees Celsius. Okay, now C3. C3 is what? The specific heat capacity of water is always 4200 joule per kg per Kelvin, even if they did not give it to you. So they are now asking us the final temperature, theta 4. Theta 4 is unknown. Theta 4 is unknown. But don't forget that what? That heat gained, heat loss is equal to what? Heat gained. Okay? And who is losing? The copper is the one losing. Okay? So since the copper is losing, I'm going to have M1C1. Then the change in temperature is supposed to be the final temperature, theta 4, minus the temperature of that copper, theta 1. But since it is loss, is not gain, so it will not be 1 first before the 4, because it is loss. Okay, is equal to, now the people that gained, the water gained, the calorimeter gained. So since the calorimeter gained, I'm going to have M2C2 into theta 4, the final, minus theta 2, okay, plus M3C3 into theta 4 minus theta 3. Very simple formula. So let us put everybody. I have my 0.024 times my C1 is 400 in bracket of my theta 1. My theta 1 is what? What is my theta 1? Where is my theta 1? My theta 1 is where is theta 1? I had 230 minus my theta 4 that I'm looking for is equal to my M2. My M2 is 0.06 times my C2. Sorry, this is C2. My C2 is still 400 into my theta 4 that I'm looking for minus my theta 2. Where is my theta 2? 31. Okay. Okay, so plus, sorry, plus my M3. My M3 is 0.054 times my C3. My C3 is 4,200 in bracket of my theta 4 that I'm looking for minus my theta 3. My theta 3 is 31. Okay, so now let us permit me to clean here and finish it up here. Okay, so finishing up, I'm having let's multiply this first. Want to clear the bracket. 0.024 times 400. Sorry, 0.024 times 400. I'm going to have 9.6. Okay, I'm going to have 9.6 in bracket of 230 minus theta 4 is equal to, open the other one, 0.06 times 400. I'm going to have 24. I'm going to have 24 in bracket of theta 4 minus 31. Okay? Plus, let's do the other one. 0.054 times 4,200. I'm having 226.8. 226.8 in bracket of theta 4 minus 31. Okay, so now what do we now have? Well, let us clear. 9.4 times 230 times 9.4. I'm having 2,162. Okay, minus 9.6 theta 4 is, I'm clearing bracket. This time this 24 theta 4 minus 24 times 31. I'm having 744 plus, this time this will give you 226.8 theta 4 minus 226.8 times 31. I'm going to have 7030.8. Okay, so now collect like terms. All your theta 4 should be one place. So then the number should be one place. So I have 2162. This another number minus, come here, become plus 744. This one again plus 7030.8 is equal to, now what do I have here? 24 theta 4, okay, plus 226.8 theta 4 plus this one coming here plus 9.6 theta 4. Let me add everything here. So plus 744 plus 2162. I have here 9936.8 is equal to, let me add here, 226.8 plus 24 plus 24 plus 9.6. I have 260.4 theta 4. So my theta 4 will now be 9936.8 divided by 260.4. So you now have 9936.8 divided by my last answer. So I have 38.16 degrees Celsius. So that is my answer. 38.16 degree Celsius. Okay? All right? Or Kelvin. Sometimes they put it in Kelvin or they write in degree Celsius. All right? So that is that. You see, it's a very simple question. Once you now know that your heat loss is equal to heat gain, you are done. Question number 10. Question number 10 said, when two okay, when two objects X and Y are supplied are supplied with the same quantity of heat, comma, the temperature change in X is found to be thrice that of Y. Okay, then I say if the masses of X and Y are the same, then I say calculate the ratio of the specific heat capacity of Y to X. Okay, so since their heat are the same, solution, so you have that M of X, C of X, and change in temperature of X is equal to M of Y, C of Y, and change in temperature of Y. All right, but they say that their masses are the same, so the mass will cancel the mass. Okay, so they are asking us the ratio of what? Find the ratio of the specific heat capacity of Y to X. So Y divided by X, so Cy divided by Cx. This one will come down, so that the other one will go down, is equal to change in temperature of X is equal to what? Change in temperature of Y. But they say that what? That the change in temperature of X is thrice that of Y. So change in temperature of X is equal to 3 times change in temperature of Y. Okay, change in temperature of Y. So what do I have? Cy over Cx is equal to what? Theta x all over. Instead of putting this, instead of putting change in temperature of X, I'll put it at 3 times this. So I have 3 change in temperature of Y all over what? Change in temperature of Y. So this cancel this. I will now have that Cy is to Cx is equal to what? 3 is to 1. So the ratio is 3 is to 1. All right. So I'm going to solve 2 more questions. They will now enter to latent heat. Right? Question number 10, we have tried. A tap supplies water. A tap supplies water at 26 degrees Celsius, while another supplies water at 82 degrees Celsius. Then I say if a man wishes to bathe with water at 40 degrees Celsius, then I say what is the ratio of the mass of hot water to cold water to that of cold water? Okay, it's a very simple question. Now, it's a very simple question. They say that well, let's take M1 to be that of the code, then M2, everything about 1 should be that of the code. So we have that what? That my M1, okay, C1, the change in temperature for cold, because when they will mix, if they mix, what happens when they mix? Okay, if they mix, the one that is cold will gain energy, the one that is hot will lose. So since the one that will gain, the one that is cold we gain, so it is going to be theta 3 minus theta 1 is equal to what? M2C2 into what? Theta 2 minus theta 3. It's supposed to be theta 3 minus theta 2, but this man is losing. So here is gain, here is loss. Okay, so my M1, the mass of M1, they say, what is the mass of the hot to the cold? So that is M2 over M1, because M2 is the one that is hot. M1 is the one that is cold. The one that is hot is losing. So this M2, in fact, their specific heat capacity will cancel out, because the specific heat capacity of water will always cancel out. So what do we have now? M2 is to M1. So this one coming down shows that these people will come down. So it's going to be equal to, I hope you understood what I'm doing. If I want this to be up, then the mass is the one coming down, this over this. Then this one that is here should go down to these people. So I'm going to have theta 3 minus theta 1 all over theta 2 minus theta 3. So this is the ratio, M2 over M1. My theta 3 is the mixture, the final one. That is 40 minus my theta 1 is the first one, which is 26, divided by my theta 2 is the second one, 82, minus the final one, 40. So what do I have? M2 over M1 is equal to this minus this. What do you have? 40 minus 26. I have 14 all over 82 minus 40. I have what? 42. So this divided by this, 3. So I have M2 over M1 is equal to 1 over 3. 14 divide this 1, divide this 3. So therefore, the ratio of M2 is to M1 is equal to what? 1 is to 3. So the ratio is what? 1 is to 3. So that is that. The ratio is 1 is to 3. Okay? So the last question we're going to solve, in fact, this is going to be your assignment. So you tell me the answer at the comment section. So your assignment said, question number 11, 250 grams of lead at 170 degrees Celsius is dropped into 100 grams of water at 0 degrees Celsius. Then I say if the final temperature is 12 degrees Celsius, calculate the heat capacity of the lead. Don't forget that heat capacity is mass times C, MC. They did not put specific in it. Specific is just C. Then I said, so that is that. That is just the simple question given. So you should know that heat loss is equal to heat gain. So in our next video, we'll now talk about latent heat. We'll talk about latent heat of vaporization and latent heat of subscribe. Latent heat of subscribe. Please. Okay, bye-bye.